Namaskar. Now next topic is solutions of gases in liquids. So almost all gases are soluble in water, though to different extent. Or we can say all gases are soluble in different liquids to some extent. And that solubility depends on nature of gas and solvent. It also depends on temperature, and very significant effect is of pressure. So these are main factors responsible for the solubility of gases in liquids. And solubility of a gas in liquid is expressed by two coefficients. First is absorption coefficient and other is solubility coefficient. Now what is the difference between these two coefficients? Absorption coefficient alpha is defined as volume of gas in cubic centimeter at reduced to 0 degrees Celsius and 1 atmosphere pressure, or we can say at STP, dissolved in 1 centimeter cube of solvent at the temperature of experiment, or the temperature at which dissolution takes place, and 1 atmosphere pressure. See, this is the volume of the gas in cc reduced to 0 degrees Celsius and 1 atmosphere pressure, which is required to be dissolved in 1 centimeter cube of the solvent to form saturated solution. At the temperature of the experiment, or the temperature at which dissolution takes place, and 1 atmosphere pressure. And solubility coefficient is volume of gas in cubic centimeter at temperature and pressure of experiment, or temperature at which dissolution takes place, in again 1 centimeter cube of solvent to form saturated solution. Right? Difference is, this is the volume of gas in cc at STP, and this is the volume of the gas in cc at the prevailing temperature and pressure of a dissolution. It can also be expressed in molarity, that is number of moles of the gas dissolved per liter of solution, or it can also be expressed in mole fraction. So these are different XD or X2, whatever you would like to say, but it is the mole fraction of the gas in the particular solution of gas in liquid. So these are units to express solubility of the gas in liquid. Now let us discuss nature of the gas and solvent, how it affects the solubility. Okay, So let us discuss first point. Let's note down. So different gases have different solubility in the same liquid. Let us say water. So in water, those gases which can react with water, for example HCl, SO2, ammonia, these gases are more soluble than those, and even CO2. These gases are most soluble in water than the gases which will not react with water. For example, when we dissolve HCl in water, what would happen? It forms product like this. Even SO2, when dissolved in water, it turns into H2SO3. If we dissolve ammonia in water, it turns into ammonium hydroxide. If we dissolve carbon dioxide, it turns into carbonic acid. So these gases are more soluble than the others which will not react with water. Then second factor is ease of liquefaction. And this ease of liquefaction of gases is proportional to van der Waals attractions. And these van der Waals attractions are proportional to their molar mass, their size, their number of electrons. So as ease of liquefaction increases, solubility of the gas in liquid or solubility of gas in water increases. So we can say, if we compare non-polar gases like CO2, O2, N2, helium, which gas is more soluble? Obviously CO2, because here it is also reacting with water. Now if we compare O2, N2 and helium, O2 has higher molar mass, higher van der Waals attractions, or we can say dispersion forces, than N2, than helium. That's why O2 is more soluble than N2, N2 is more soluble than helium. Helium, hydrogen, they are least soluble in water because their dispersion forces are very weak, because their molar mass is very low, their size is less, their number of electrons are very, very less in number, right? That's why helium or hydrogen are least soluble gases in water. So ease of liquefaction, and those gases which react with water are most soluble in water. Okay, so this is about the nature of gas and solvent. Now next is temperature. Now effect of temperature. Before that, we say O2, N2, CO2. Say they are more soluble in ethyl alcohol than in water. But ammonia, H2S, they are more soluble in water than in ethyl alcohol. So it is because of chemical similarity between the gas and the solvent. Because water is more polar than ethyl alcohol. That's why O2, N2 and CO2, which are non-polar, are more soluble in ethyl alcohol than in water. But ammonia, H2S, they are polar, and therefore water is more polar than ethyl alcohol. That's why ammonia, H2S, HCl, they are more soluble in water than in ethyl alcohol. Now let us discuss effect of temperature. So in most of the cases, when gas is dissolved in any solvent, the process of dissolution is exothermic, because when gas is dissolved in any liquid, gas gets liquefied. So when gas is liquefied, that means attraction between the gas molecules increases. So in most of the cases, process is exothermic. That's why when we increase the temperature, solubility of gas in liquid will generally decreases, with few exceptions that we will discuss in the same part later on. So on increasing temperature, solubility of a gas in liquid decreases, and to see the quantitative effect, we will use the equation just like Van Hoff equation, d natural C over dt equal to delta H over RT square. Here C is concentration of gas in liquid in moles per liter, means molarity. This is molarity of the gas in liquid. T is temperature in Kelvin, R is gas constant. Now it is called solution constant. It is just like gas constant. And delta H is enthalpy of the solution. Most of the cases it is exothermic, and it is also expressed as natural log of C2 by C1 equal to delta H over R 1 upon T1 minus 1 upon T2. This is quantitative effect of temperature on the solubility of a gas in liquid. Now I am talking about the exceptions. So sparingly soluble gases like hydrogen and inert gases. Keep in mind, hydrogen and inert gases, their solubility increases on increasing temperature. Except this, all other gases, their solubility decreases on increasing temperature. This is only exception. So note it. Then we will do one question related to the same part. So see, temperature effect. Most of the cases, dissolution of the gas in liquid is exothermic, and that's why solubility of gas and liquid decreases on increasing temperature. And to see the quantitative effect of temperature on the solubility, this is actually solubility of the gas. So in liquid, so this part, this equation is used. This is extended form of this equation, just like Van Hoff equation, Clausius-Clapeyron equation, that you know. Okay, just note down, and then we will do that question. This is very important. So this is the question, and ready-made answer is there. That why do aquatic species feel more comfortable in the lake in winter than in summer? So you know, in winter temperature is low, so solubility of the oxygen gas is more, so more oxygen is available for breathing, and that's why aquatic animals feel more comfortable in winter. But in summer what happened? Temperature is high, so solubility is less, so less oxygen is available for breathing. That's why aquatic animals feel more comfortable in winter than in summer. So this is the answer. Just note down. Same answer you can write in your exam. Okay. So thank you very much for watching this video. Do like, subscribe and share my channel. God bless you all. Happy learning. And effect of temperature on the solubility of a gas in liquid, we will make a separate video. In the next lecture, we will do that part that is called Henry's law. Very, very important. Don't miss that lecture. Okay, thank you.